Hi, it's Steven at Leg Up, and I just wanted to do a walkthrough of what I'm working on here with Atmel Start. I'm just playing around with the SAMD21 chip that is using the CircuitPython from Adafruit. Want to just play around, so I looked at the Atmel Start, and it has a thing to set up a project, and but I wanted to build it from the command line. So I kind of played around with it a little bit. I'm gonna walk through it now, see if it works, and if it does, I'll upload the video, and hopefully it's helpful for somebody. Um, so let's get into it. So the website is start.atmel.com. Oh, that just brings up this. It's just a wizard, I guess, to get started. Create a new project. Then you can choose whatever combination of things you want to filter down what chip you want, but I already know sort of the family. I want a SAM D 21G, I think. Yeah, and then so we'll do this one, and that'll work. So we choose a chip, click create new project. That will generate whatever it needs to do in the back end. You can so it kind of gives you a visual of the things that it's added in already for you. The name just by default, I guess, is my project, so you can rename it. I don't know if it matters. You can do this now or later. So you give it, this is just the code name that my daughter named this one. We just randomly generated that. So then you can, I'm not really doing a tutorial for Atmel Start, but this is how you just get started. Choose your peripherals, and then I2C, let's do that. And then add components, just to get something started here. These don't really matter right now. All I'm really concerned about is getting this project so that I can build it. So that, there we go. That's that should do that. So that's just a basic project. So then what I want to do is, so this is where I got to before. So you do export project, and it wants you to use Atmel Studio, I guess. I didn't want to have to download that for a few reasons. I don't want to have to put that on my my dev laptop right now. I want to actually build in Linux using automated tools and things, or do it in Docker. So I want Makefile. So I've checked the Makefile version. So it's gonna bundle it up, and I guess just give me both. So download the pack, and it will ask me where to save it. So I'll just save it there. So it's not very big, less than a meg. And then also take a look. Where is it here? So then, so the file. So it's called AT. It's an AT zip file, which I'm pretty sure is just a zip file that they've just changed the name of. So I'm going to. Actually, I don't need it on this box, so I'm going to send it over to my Linux box. Okay, so I want to I'm just going to FTP it to my other box here, and do see work area projects, I think. Nope. Work area. Oh, just project. Dangerous D. Nothing there. Okay, so I'll just send that file. And then I can just switch over to my Linux box. And then unzip. Dangerous. Okay. All right. So then, so now this has given me the source with, and the Makefile I think is in here under GCC. So it's just a generated Makefile. Now it's using the ARM GCC, which I know I can get, which I don't have on here at the moment. So let's download that. So we go to Atmel GCC, and we should be able to, how to install, no. No. We'll just write the first one, of course. So then this has, what I want is the ARM GNU toolchain 64-bit. I believe that's, yeah, so I think that's what I want. So I want to download that, so copy a link address. Let's take a look. Okay, so it's, yeah. All right, so that's pain. So here's, I'll just have this little trick when I find, it can run into one of these where you don't actually download on the files, you just can't copy the link. So open up the inspector in Chrome, and then click on what you want to download. So that's that one, and it will start to download it, but you cancel out of that, and this is the file that I actually want. You can copy as curl bash, which is all I really want, and I want to put that in here. So I'm going to just make xc, and I can just paste that. Now that will by default want to write it to the screen, but I just want to output to, and the file name is right here. So whoops, I can just copy paste that. There we go, and then that will output the file, and that shouldn't take too long. Where are we at? So 65%. So that will just download the file directly. That's just a side thing. So then I can extract that, ARM, extract tools, and that will give us here standard stuff here. So this is the directory where my tools are. So I can just do export path equals path and paste that in. So now the tools should be in my path. I'll just double check that I did that right. So which, and good. So then I should be able to now go into here and just run make, and it should work. It seems to be working. It's running GCC, compiling all the stuff, and we get a warning that baud rate's too low. That's not a big deal. So there's a few things. So warning, clock skew detected. Those are things I'll have to take a look at later. But as far as what we've got, it actually built our binary. So we've got our elf file, bin file, hex file, map file. So yeah, that's got everything that I wanted. And so that's we're off to a good start. So I'm happy with what we got there. So then I can use that to start with the project and experiment with that. Hopefully that's helpful, and you can let me know if it was. I would love to hear if anybody watches it or if anybody finds it helpful. Thank you very much. Thanks for watching.